what information do you know about acceleration if the position versus time looks like a smiley face, sad face, or a straight line? When you have a position versus time, this is not the same thing as velocity. And it turns out if your position versus time graph is curved, then that means your velocity is changing. And if your velocity is changing, that means you have acceleration. So if we have a smiley face, okay, this means that we have positive acceleration. If you have a sad face, that means you have negative acceleration. And if you have a straight line on a position versus time graph like this, that means your velocity is not changing. It's constant velocity. And so that means acceleration is equal to 0. So you have no acceleration. Okay? So looking at these graphs, let's take a second here. And we're trying to figure out which of these graphs is a smiley face shape. Now if I take a look, I can extend this graph right here, and this is a smiley face. So this is your smiley face shape, and this one's your smiley face shape. So here's my smiley face shape. Okay? Of this shape, this point right here is a minimum. And then if I come over here, the minimum is located right here. And then for a sad face, that's negative acceleration. So here's positive acceleration. Negative acceleration is if you have a sad face. So the thing is, you may only have half of that sad face, but this is a sad face curve, all right? If you are in calculus, you would say that this is concave down, and this is concave up. So here's a sad face, and here's a sad face. So sad. All right, so this point right here, that is a maximum. And this point right here is also a maximum. All right, so using the position versus time graphs above, place the appropriate labels with the provided acceleration. All right, so I have graphs A, B, C, D, and E. And what I'm going to do then is I'm looking for the one with 0 acceleration. Well, if you have a straight line, that means your acceleration is not changing, and so that's going to be A. This is a straight line. It has 0 acceleration. Positive acceleration is the smiley face. Well, I have 2 smiley faces. That's at B, and that's at D. And then I have negative acceleration at the sad faces. That's at C, and that is at E. Now, to get the motion from a position versus time graph, so this is only just acceleration. It's identifying this is positive, this is negative, this is 0. But to get the motion, right, we're going to talk about how we can tell when it's speeding up or slowing down or maintaining constant speed. So it turns out that you are speeding up if you are moving away from a turnaround spot. All right, so you stop when you turn around, and then you can speed up from that point. So what I mean here is right here, this is a minimum. So what's happening is I'm barely moving. If I looked at the slope of the tangent line here, they would just be small slopes, and as I get further and further, my slope gets bigger. And the slope of a position versus time graph is velocity. What does that mean? That means you're speeding up when you move away from a max or a min. All right, so if you're moving away from a maximum or a minimum, you're actually speeding up. Now over here, I'm moving toward this. So what's happening is I was going fast, and then I'm slowing down to a stop. Then I turn around, right, and then I start speeding up. But if I'm moving toward the maximum, or I'm moving toward the minimum, okay, then that means that I'm slowing down. So we move toward the max or min point. So if you're moving toward the max or min of your curve, that means you're slowing down. Now you are stopped when you are on the max or the min. Okay, you're stopped because that's generally your turnaround spot, or when you're changing from moving in the positive direction to moving in the negative direction. And you're maintaining constant speed if this is a straight line. Okay, so it could be straight line horizontal, or it could be straight line with a positive slope. It could be straight line with a negative slope. So anytime it's straight, that means your velocity is constant. It's not changing. So using the graphs, we are going to label again, but this time we're going to label maintaining constant speed, speeding up, or slowing down. So let's take a look at the maintaining the constant speed. This means that the acceleration, if we're maintaining constant speed, acceleration is 0. When does that happen? That happens anytime you have a straight line, and that is going to be A. Speeding up, well, let's take a look here. So speeding up is when we're moving away from a max or a min. So max or a min is where we're stopped. So if we're moving away from it, then we're increasing speed by moving away from that. So we need to figure out when do we start at a max or min and then move away from it. So here it's a straight line. Nope. Here I'm starting at a minimum and I'm moving away. Here I'm starting at a maximum and I'm moving away. So for B and C here, so it's B for the positive acceleration and C is the negative acceleration. So what's happening for B is I'm moving away from the min in the positive direction. Okay, so I'm moving in the positive direction with positive acceleration. For C, I'm moving in the negative direction, right? And I have negative acceleration. So negative and a negative, then we are speeding up. Okay, so if your acceleration is in the same direction of your motion, right? So here I have a positive acceleration. So here, positive acceleration, and I'm speeding up in the positive direction. So I'm moving in the positive direction. So moving positive, so therefore speeding up. So I'm moving in the positive direction, so I must be speeding up. C, I have negative acceleration, and I am moving, I'm moving away from this, so I'm moving in the negative direction. But remember, for negative acceleration, right, I need a negative with a positive, so I must be speeding up to have negative acceleration. All right, slowing down. That's going to be these two guys. Here, I'm moving, I have positive acceleration, so this is D. I have positive acceleration, but I'm moving in the negative direction. So moving in the negative direction. But if I have positive acceleration and I'm moving in the negative direction, then I must be slowing down because they have to be both negative or both positive ideas in order to be positive acceleration. And then here I have my sad face, so that's negative acceleration. So this is E. Negative acceleration, but I'm moving upwards, so my displacement is in the positive, so I'm moving in the positive direction. But if I have negative acceleration in the positive direction, I have to be slowing down.